Use a trapezoidal sum with 4 equal subdivisions to approximate the integral between 0 and 4 to 3x plus 2 dx. All right, so let's label what we know. Let's label what we have. You would be like my upper limit. You would be my lower limit. Okay, you would be my subdivisions. Your f of x. Okay, if you know my Riemann sum videos, if you've seen those, the beginning is exactly the same for the trapezoidal sum. Okay, the change of x is going to be like if I were to graph this out, right? If I were to graph this out, it's going to look like that. Okay, but what we're dealing here is we're not dealing with writing out rectangles. We're now dealing with trapezoids that we will build to kind of come up with an approximation. All right, that's what we're dealing with here. So what I have to figure out is how long. I know it goes up from 0 to 4. I have to, if I'm using 4 subdivisions, I have to find out how long these are and how tall each end is. Okay, so let's do that. The change of x is going to give us how long these are. So that is calculated by b minus a over n. b is going to be 4. A is going to be 0. N is going to be 4. 4 minus 0 is 4. 4 over 4 is 1. So that tells us each of these are going to be 1 unit long. Okay, so from 0 to 1, 1 to 2, 2 to 3, 3 to 4. What I don't know is how tall each of these are. With Riemann sums, we focused on rectangles. Well, with trapezoidal sums, we're focusing on trapezoids. So I don't just want 4 of them, I want all 5 of them. I want to find out what f of 0 is, I want to find out what f of 1 is, I want to find out what f of 2 is, what f of 3 is, and what f of 4 is. So that's going to be my next step, is to use all of the endpoints to find what I have. Not so much just, some of them. So I'm going to find out what f of 0 is, f of 1 is, f of 2 is, f of 3 is, and f of 4 is. I use that by using that formula right there. 3 times 0 plus 2 is nothing plus 2, which is 2. 3 times 1 plus 2 is 3 plus 2, which is 5. 3 times 2 plus 2 is 6 plus 2, which is 8. 3 times 3 plus 2 is 9 plus 2, which is 11. 3 times 4 plus 2 is 12 plus 2, which is 14. So this end of the trapezoid, that height right there, is 2 units tall. You're 5 units tall, you're 8 units tall, you're 11 units tall, you're 14 units tall. Now, if I wanted to, I could take each trapezoid and use the trapezoidal area formula and kind of calculate all 4 of these individually, which wouldn't be the end of the world. But in this case, what I'm going to do is I'm going to use the trapezoidal sum formula, which is going to be the change of x over 2, so 1 over 2, and it's going to be the f of whatever plus f2, f of what. Now, let me actually write out the actual formula first, because it's a gross formula. Let me actually write it out. It's change of x over 2. Okay, and all of this is coming from the idea of the area of a trapezoid, but we're adding a bunch of trapezoids. Okay, the change of x over 2. You will insert f of x sub 0, which means the left guy, plus 2 f of x sub 1s, plus 2 f of x sub 2s, and you work your way all the way until you get to the very end, f of x sub n, and only one of those. Again, this is basically me coming up with the trapezoid formula, but adding a bunch of up. Now, what this looks like here in this case is since f of x, or the change of x, was 1, it is going to be 1 over 2, like I said. F of x sub 0 would be me plugging that guy in, which is going to be 2, plus 2 times f of x sub 1 would be me plugging in 1, so 2 times 5, plus 2 times 8, plus 2 times 11, and then the very last one doesn't get multiplied by 2, it's just 14. Okay, this gives me the area of all of the trapezoids. Okay, 2 plus 5 plus, so again, 1/2 of 2 plus 5. 1/2 of 5 plus 8. And so 5 is being used twice. 8 will be used twice. That's why these are 2's. All right. When you do all that, you get half of 2 plus 10 plus 16 plus 22, the Taylor-Swift special, plus 14. All of these numbers on the inside add up to 64, so half of 64 is going to be 32. And based on the picture that I drew, that is going to be an extremely accurate, if not an exact answer. Okay, so trapezoidal sum, wacky stuff, but fun.